First of all, welcome to 2021. Hopefully, you all will be healthy and fine and enjoying good health and had a wonderful holidays. Okay, so far 34 students have joined today. I'm going to share my screen. And first of all, today the agenda is that we will discuss the solution of assignment number two, which you all have already submitted. So can you see my screen? A yes in the chat would be good. Okay, good. Great. So the assignment number two was that you had the deadline was 7th of January, which is already gone. So please hand in your solution via Moodle, blah blah. So it was about principal component analysis, and the first question was that let X belongs to R P cross N, where P is less than N, be a centered matrix of n-dimensional data. Examples with full size of SVD X is equal to blah blah blah. So, and then we assume that the singular values are sorted in a descending manner. So the first part was that provide a normalized vector S hat that lives in RP such that S hat is equal to the argmax of this. Okay. So now we are going to look at the solution. Okay. So this is the solution. So it belongs to one of the students from the last year, but it is good enough. So we will go through the solution one by one. So in the task 1.1, our aim is to obtain a normalized vector S such that it is the argmax of S transpose sigma, sigma transpose S. So if looking at the right hand side, you can see that argmax of S transpose sigma, sigma transpose S can be written like this. So we just take the transpose and we just rewrite it as follows. So I hope this is simple enough for everybody. And then as you can see that this is just a multiplication of sigma transpose S. So it would be sigma transpose S squared. So this denotes the norm, right? The L2 norm. Okay, and then we say that this sigma transpose S is nothing else but the diagonal entries sigmas multiplied by the respective values S. Okay, so as you know that sigma is a diagonal matrix, so we can simply reduce this thing into the sum of the scared values of sigmas with sj's. So if nothing is if there's any problem, please feel free to write something in chat. Okay, so great. With that we can say that with the given sigma, because in the question, as you already know that in the question it was uh, yes, this was the question. So in the question you see that it was already assumed that the singular values are sorted in a descending manner. Okay, so with that in mind, so if we look at this now, that it means that all the sigma squared values should also be greater than 0, because if the individuals are greater than 0, then squared would also follow the same pattern. Okay, so this also implies that sigma square into Sj should be less than or equal to sigma square into Sj. This also holds as well. So the normalized vector is a unit vector that has length 1. So it further implies that S hat is equal to S hat square is equal to 1 and S hat square is equal to 0. I mean, the reason is that only the ith or the jth entry would be 1. All other entries would be 0, right? For this S hat. And if we take a square root of this, then it would be plus minus 1. So this means that the first entries are minus 1 or 1 and the other entries are 0. So this is actually, okay, why is this sharing not working fine? Uh, uh, well, yes. Okay, so as we can see that now this part is done, and now we want to show that the empirical variance of the inner products of the columns of X with a normalized vector A is such that it is maximized when A is a set when A is set to the first column of U, that is A is equal to U1. Okay, I mean there was also a hint in the question that the norm of A is 1, right? And we further gave a hint that A as a write A as a linear combination of the columns of U, verify that such a representation does not affect the norm constraint. Okay, let me also just add one thing here, that this solution which I'm showing you is only one way of doing or performing this task. I mean, you can do it in multiple ways as long as the basic intuition is satisfied and the answer is there, right? So just keep in mind this is only one way of doing it. There are many different ways of showing these things. Okay, so for showing that empirical variance, so we can write 1 by n to sigma 1 to n A transpose x squared like this. And then further, we can decompose x and x transpose into its SVDs. And then similarly, you can say the V transpose V would be identity. And then we have sigma transpose left. And then since U transpose A can be set to B, we can then see that this equation becomes 1 by n sigma transpose B square. All right. So from 1, we found that B transpose, I mean, from 1 means from part 1, right? That B transpose B is maximized when B transpose is plus minus 1, blah, blah, blah. All the entries are 0. So B is equal to U transpose A, and then we see that U transpose is identity. So it also implies that A should be U1 plus minus. So it should be the first column of the U matrix, right? So this pretty much shows it. So there's another way of doing this, and I'm just briefly mentioning it here. So this is more like an argumentation that how we proceed from A1.1 to A1.2, but you can see that the basic intuition is the same. Okay, so this is another way of doing it. Are there any questions? Please use the chat. Okay, I think there are no more questions. So let's go to the point task 2. And for this task, download the modified version of the Yale Face B dataset which we provided on the Moodle. And the Yale Face database B consists of single light sources and 10 subjects, and each seen in different pose and illumination conditions. So it in the provided form, the database is divided into 5 subsets, and in subset 0, the subject is illuminated by almost a frontal light source, while for subset 1 to 4, the light source is gradually moved, okay, along the horizon. So then we had 3 programming tasks. So first was to write a function that takes as an input matrix T of vectorized images from subset 0. The output of this function are the 20 singular values, right? And display the first 3 vectors as images. So you have to reshape them to size 50 by 50 and then display them, right? Okay, so let's see at one possible implementation. So one possible implementation is that you define the path, blah blah, and then you load image as vector, right? And then you can use, like we used in the tutorials, image IO library. So you read the image and then you center the values by subtracting the average from the image vector, right? And then to load as a matrix, what you need to do is that uh, you first you want to see the how what are the person, right? So this matrix should also take into account number of person, number of subsets. So for person in person, and then we just want to arrange in this fashion. Okay, another implementation for this could be that which is quite simple enough, is that you first define a vectorized image, and then you, let's say, have image, and then you first get the image label, and then you have the image path, and then you open the image using the image library. Okay, and then you just use the revel function to vectorize it, right? So there are like many different implementation, like I told you. So you are using here revel, and in the other, what we are doing is, okay, okay, and in this implementation we are doing it in a much more concise way. So both are okay as long as it gets the job done. Okay, so now again here we are also doing this image folder to dataset. So we are trying to create a matrix T, right? And then to visualize the a vectorized image, the shape is already defined, 50 by 50 in the question. So we have an image array, and then we try to show the image plotted in the grayscale, right? Okay, even if you don't plot it, then it's still fine. The solution would still be okay. So now let's go to the next part. Write a function. Write a function that takes. Okay. Yeah. Before going to that, so there was also that we have to show that first three vectors as images and then reshape them to size 50 by 50, right? So the number of filters component is set to 3, and then that, for example, this is just any three random images from the set 0, I think, right? So you can see that in the first it would look like this, and the second image would look like this, and third looks like this. So here we understand that here some sense of brightness is being focused on this first principal component, but we will go into detail in the next exercises what's happening here, right? But it's uh, just so that you can visually see what's happening here. Okay, and then write a function. The second part is that takes as an input the training set T, a matrix composed of vectorized pictures from subset 0, and then the whole thing, right? So it was a quite involved task where you had to plot the error rate for each subset, and also you have to calculate the error rate, right? So let's just jump into it. So what we are doing here is that we first load the subset S1, 2, 3, 4, right, as matrix. Similarly, as we loaded S X train and X labels there, right? So then this is one implementation of how could you calculate the classification loss or classification error rate, to be precise, and then how to plot that. I'm not going to detail into into the implementation because it was pretty straightforward, and you could also guess that by looking at the graph how should your graph look like, right? Okay, so let's see at this subset one. Okay, so if what we're seeing here is that this blue curve is all principal components, and this yellow one is without the first three principal components. And as you can see that as we increase k, the error rate decreases for both of them, right? But if the orange line without the first 3k, the error rate decreases sharply. As you can see that if we have like k is equal to 3, then we are around 0.18, while with all principal components we are around 0.6. So this is for subset 1, and then we see a similar behavior for subset 2. Okay, but here like the error or the trailing error is quite high, quite low here, and it's quite high comparatively. So it's like the generalization error in some sense is quite high for subset 2, or you can say the test error is quite high there. And the situation is quite worse when we look at subset 3. So here you can see that the orange and blue lines, they are almost overlapping each other, and the test error is quite high. It's not going down, right? It's approximately 0.65 or something like that. And it is even worse in subset 4. Here it doesn't matter whether you are using first three principal components or not, right? You have a very worse performance. So it's 0.9 almost error rate. It means that you are uh, just doing anything probably by chance. Okay, so there's no actual learning going on here because the error rate is almost flat. It doesn't matter how much case you are using, how many personal components you are using. Okay, so then what we are doing is this is just another way to show it. I think it was not part of the task, but it is just one way to show that if we combine all the subsets and only train on the subset 0 and combine in the test set all the subsets 1 2 3 4, then the error rate is almost around 0.5, right? And here also the blue and orange are almost overlapping with each other. I mean, yeah. So are there any questions to this? I mean, hopefully by seeing these curves you would have understood whether you did your implementation correct or not, because these curves tell the whole story about the implementation. Okay, okay. So now I think the question was, how do you explain the difference in the recognition rate, right? So we have plotted the error as before, but we see that there is a difference in the recognition rate for, let's say, subset 1, right? There was a difference, right? And also for subset 2 there was a bit difference, but for subset 3 and subset 4 there was no difference at all. So let's see what is happening and what could be the possible explanation. Okay, so the recognition rate has increased for the first two subsets after removing the first three principal components. Since subset 1 and subset 2 have better lighting condition, I would not say better, I would say similar lighting conditions, right? Because if you remember, uh, it was moved gradually from along the horizon from subset 0 to the subset 4. So they have similar lighting conditions, and in some sense also better, because when you move it along the horizon, then you have plenty of light being not on the face of the object or the person, but you have light probably perpendicular to one face angle, and then there's a shadow on the other part of the face. Okay, and the first three principal components mostly correspond to lighting. The lighting is assumed to be removed after leaving them out. Okay, the focus is shifted towards features that correspond to the human attributes rather than the lighting condition. So, and also subset 3 and 4, if you open them physically, open them in the form of an image, and then you see that they're really badly illuminated. So that's why probably subset 4, neither of the two methods were able to classify. The average score is around 0.9, which is approximately same as for a random guess. Okay. So you can see that this tells us a lot about what's happening underneath. What is the intuition behind behind the first principal components. So first, since the data, the variance in the data is captured mostly by the lighting condition, so that dominates the first three principal components in some sense, right? Because you remember, kernel PCA is not talking about what kind of information you have, but what kind in the data has. It's not interesting. It is not interesting for the kernel PCA, right? The kernel PCA, oh sorry, the PCA is interested in getting to know what kind of variance is in the data, right? And for the first three principal components, we see that the brightness represents the most variance in the data. Okay, so I hope this is much clearer to you guys now. And just as another possible explanation, I'm going to tell you another possible explanation for this. Okay, so how do you explain the difference in the recognition rate? So the minimum errors achieved by removing the first three principal components is less than that of using all the 20 single vectors. This is quite unexpected because singular vectors should capture most of the variance in data. Having a look at the data, one possible explanation for this could be that those first three singular vectors capture more noise than useful information. That's why they contribute more to misclassification. Okay. Another possible explanation is that training and test data do not follow the same distribution. This is really important, that the training data and test data follow quite different distributions, right? So because it came only from one subset with specific lighting conditions. So it is not so the training data is not representative of the whole dataset population. So probably a very good idea would be that you should choose some images from subset 0, some from subset 1, some from subset 2, some from subset 3, and then create a training set out of that, and then use the rest of the images uh, for testing. And then the error rate would be quite low. So this is a really important lesson for you guys, that there should be the distribution of the training and test should be kept as similar as possible for us. So we should not we should look physically also at the images and see uh, whether the training images are of specific type, and the validation images are of specific type or not. Because if the training data is biased, in this case it was biased towards light, then you could not get very good uh, test error or generalization error. It would be really, really poor because you train for a very, very biased and very, very specific data set. Okay, so now we take 5 minutes break and we join back again at 10 20. Okay, and then I will explain you what would be the format of the exam. This is really, really important, so you all should join back. That what would be the format of the exam, and and how the exam will be conducted. Okay, so this is really, really important session. So let's see each other at 10:20 and continue. Thank you. So I was telling the students that the exam will be MCQ based for this semester, information retrieval, and it would be done via Moodle quiz, and you would have limited time to do that. All those details would also be shared through Nachrichten, I mean through the news in the Moodle, right? So that you don't need to worry a lot. But you should uh, if you have any question, then I would really like that you ask them in the class, because it's not really possible to answer them on the Moodle, right? So I hope that you guys listen to this and tell it to your fellow students or your classmates. So the MCQs questions will be, I mean, this is one of the sample MCQ question. So you have four options or three options, and you have to figure out an answer. So I was asking you guys that can you please tell me which one is the odd one out? You have to pick. So let's say that this guy on the left is number one, this is number two, this is number three, and this is number four. Okay, let's see. Number two. Oh, great. You guys have great observation power. Yes, the number two is the odd one out. So can you please tell why? I mean, if you unmute yourself, Amelios, or I don't know, Julian. Yes, because of the shoes. Yeah, yeah. Okay, yeah, yeah. So yeah, that's the reason. And the second reason is that he doesn't have the handkerchief on his coat. Okay, so enough fun. But the exam would be also fun. You would, although you would have to figure out, I mean, do some calculations. That I'm going to tell you already that there would be a lot of calculations in the exams. So please have a pencil and a calculator and a paper with you, so that you can solve something like matrix multiplication and stuff like that. So it would be really good if you have a calculator and a and a pencil with you and paper. And the second tip for the exam is that it would be really, really great if you guys can have a general understanding of the topic. Then probably like 50% of the time you don't have to do calculations, because you understand that if something is orthogonal, what does that mean, and how would that fit into the matrix multiplication. So it makes your life easier. So it is also a very good tip, so that you have to apply those concepts practically. So I think there was some question. Okay, so is that multiple choice or single choice? No, it's a single choice. So to avoid the confusion, we will only have a single choice. So there would not be like multiple choice. So you have to choose only one option, right? Out of the given three or four options, you have to only choose one option. And I would also try to create uh, probably a like a mock quiz where we have only like one or two example, and then you can see that what's the flow. I mean, it would be really, really simple. You guys are all very intelligent. I think it should not be that much problem to solve a quiz on Moodle, right? So, but just to be on the safe side, I would give you uh, a mock example also on the Moodle, right? Yes, all the questions will be the MCQs. Okay, so Li Xiang asked, yes, all the questions will be MCQs. There will not be any essay question or fill in the blank questions, nothing like that. All MCQs. We want to keep life simple and easy, just like this MCQ, right? So don't worry. Okay, so there's another question that will there be a coding related task? Okay, Jigit, there will not be a coding related task, because we do not want to check that. Okay, because that is already being checked in your assignments, that you could do a good coding, right? And you understand the concepts well. So that coding will not be a part of the exams. Okay, and let me clear one thing more. There might be some intuitions or some insights which you learn from the labs, and which you learn from the lab exercises, and which you learn from the assignments, that could be part of the exam. But it would be like maybe those intuitions will help you. Like I just give you a hint that if two matrices or two vectors are orthogonal, what could be their product, or I mean, and how to check, let's say, if a certain function is a kernel function or not. So stuff like that, that is probably mainly based on your intuition and insights. If you are uh, taking the lectures and taking the tutorials in a quite what you can say, quite attentive way, right? Then that would help you a lot. Okay, so people, hold on your horses. So many questions in the chat. It would be really fun if I could hear you guys because it seems like I'm talking to a wall. You know, don't try. Okay, so what was I saying? How long will be the exam? Okay, good question. And then there's next question that how when do we get the assignment grades? So many questions. How will the exam be supervised? Martin. Ah, that's a really interesting question. Okay. Okay, let me turn on my video so that you can see me too. I don't know. Everybody can see me? Okay, yes. So I'm talking, not talking to a wall. Martin, where are you? Okay. So Martin said, will the exam is supervised? The problem is that it could be supervised, but we do not want to go into that direction, frankly, because what we want is that you guys understand the concepts and you can answer some basic questions in that area. This is number point number one, and point number two is that you can also do some calculations so that if you are if you have to solve some matrix multiplications, then you can do it in regards to information retrieval or in reference to information retrieval concepts like PCA, kilo PCA, or neural networks. You understand the basics and you could do uh, those kind of things. So and we do not want any surveillance of that. So it would be simple model quiz, and we trust you guys that you would not do funny things and things that you are not supposed to do. That is a matter of trust because these are very uh, challenging times, and they should teach us that we have to trust each other a lot. Okay, because the goal is not. I mean, we could arrange some kind of surveillance, but Martin and I discussed, and also the department, we said that we should believe in the students, we should trust them, that they would not do funny things. Okay, because even if you have surveillance, people can always do funny things. Those who want to do right. So please, we trust you. Don't break our trust. Okay. So Francesca asked, "Is it an open book exam?" Yes, it is an open book exam. Okay, and I mean we are putting it out on the mural and giving you like 1 hour 20 minutes. So it would be something like that. I think 1 hour 20 minutes. So it would be enough time, right? So we have not yet defined the exact time, but it would be enough time. I mean, if you know it, then you could probably do it in 40 minutes, right? Not more than that. So we will still give it you double that time. So I was able to do this exam in like 25 minutes. So I would give you 3 times that time, so that sometimes you some people are not very fast in doing their calculations, and I do not want that the time of calculation be. I mean, we are not checking your speed of calculating things, right? We are checking your ability that you can calculate them, but not the time. So we would. I mean, time would be very relaxed. Okay, enough on the time thing. I mean, the exact time and all those things would be announced on the Moodle, right? So, but in principle, what we have decided, I have told you guys, right? Okay. So, uh, how long will be the exam? How much time? When do we get the assignment grades? That's really interesting question. I will come to this question a bit later. Julius asked. Okay. Okay. Now, how is the time counted? Limited time for each question, or say 1% of them, and we can arrange it ourselves. No. This is going, we have to keep things very, very centralized, and we have to control them in some form, and we have to be fair, right? So the exam will have a limited time, let's say 1 hour. Okay. And this 1 hour, okay, let me just probably, okay, I would stop sharing and just see. Okay, I'm opening the exam. So that's why I have stopped sharing the screen so that you guys cannot see the exam. You know, then it would not be that much fun. Okay, I just want you guys to focus on. Oh, you see it. So last time the exam was 90 minutes for these MCQs, right? So, and this was like some kind of format for the exam. Okay, and then we would try to keep 90 minutes time. We think it's enough. I mean, we could reduce it to 60 minutes. That should also be enough, but just in case somebody needs more time. So it is more than enough, like I said. So, okay. And then the exam structure, I'm just showing you roughly. Okay. So it would be like 25 questions with three possible options each. Okay. So every task would be numbered, and so let me just show you. So this would be the like the mock questions which are in the PDF format, but we will upload into the quiz format so that you could solve them. So yeah, example task is like this. So you have this formal definition of the function, and we want to say that consider the vector x, which one of the following does not hold. So for f of x is equal to 1, f of x is equal to 3, f of 2x is equal to 6. So the keyword is does not hold. So definitely f of x is equal to 1 does not hold, right? It's pretty straightforward. So simple, straightforward questions like that, right? Okay. And then this is really important. In some sense, a good news for you guys. So for each correct answer, you receive 1 point. And for each incorrect or missing answer, you receive 0 points. So there's no negative marking in the quiz. So, yeah. And most importantly, since it would be modal based exam, so there's only one attempt. For the whole paper, there's only one attempt. This is really, really important point. You do not get to make one attempt and then say, okay, let's do another attempt. That's not going to happen. Okay. I hope this is clear. Okay, back to our beautiful screen. So we have almost 24 to 25 MCQs, and each carries 1 mark. So that is the format of the exam. So 24, 25 questions. Okay, and I will show you the structure more in detail. But let's just see, are there any more questions? Blah 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 blah. Where is the chat? Here it is. Can we pass some questions and come back? Ah, Batu Khan. So, Batu, it is quite possible that you do, what is called, you can revise your answer to the question. You can come back. That would be allowed. I mean, moving between questions is allowed. That you, for example, you attempt question number 1 and then you do skip, and then you go to question number 5 and then attempt that, and then you go back to question number 2. So this is all allowed. Probably I would also allow that if, for example, if you want to change an answer to a question, for example, you have selected option A, and then when you come back, you say, oh well, who was that guy who selected option A? He was stupid. So maybe I should select option B. So that would also be allowed. But what will not be allowed is that once you submit the exam, after that, there's no second try of the exam. Okay. So there is second try of the questions, but not second try of the whole exam. This is not, or part of the exam. This is not allowed. Once you have submitted, that's it, gone. So be very, very careful when you hit the submit button. Okay. So just again, like I told you, I will try to arrange some kind of mock exam so that with some 2 or 3 silly questions like these beautiful questions. Probably this would be a part of it. Yes, I really like it. So then we have some mock exam, and then you can just test it out so that there's no technical difficulty in answering the questions, right? Because we do not want to check those things. Okay, I'm going to stop my video. Now I feel I'm talking to people because I see chat. Okay, how is the exam counted? Blah blah. Yeah. So okay. Yeah. Again, so there will be, let's say, I mean, we will. I think already a time announced on on campus TUM, I guess, of the exam. I will check it and I will announce it in Moodle anyhow. That what would be the date and time of the exam. So the date of the time of the exam would be fixed. It would be defined and limited. So it's not like you have 1.5 hours in some on Wednesday and you attempt it. It's not like that. So you all students have to attempt the exam on the same day at the same time. Okay. So I mean, we don't care if you are in South Africa, USA, or Germany, or France, or China. So so the time zone you have to be available for that specific time. Okay. I mean, definitely for us, the reference is the Germany time, right? So that time would be announced via Moodle, and also I think it would also be available on campus TUM online. But let's say that we would restrict to the Moodle, right? It would be announced, and you have to be available during that specific time. Okay, so this is really crucial. So okay,
Sorry.
yes, yes,
Yeah, I have a quick question regarding that. I thought in campus online we already have the 4th of March at 8 a.m.
yes, yes. Yeah, yeah. So
Okay, so it's the same.
yeah, yeah. I mean, I don't want to mention the time and date here now because maybe it's not very quantified and some people take it out of context. So I would make a screenshot of the time and post it on the Moodle,
Okay.
and so that's very at a very highlighted position because you understand that it's like on the online thing, everything is going on online, and some people are not that tech savvy, so probably they get confused what is the time and what time zone we have to fix ourselves to. So we will do it as per campus to online, but I will also announce it via Moodle so that there's no confusion at all. Because we do not
Okay.
want, I mean, this is really, really crucial point, because if you say that I mistook the timeline or mistook the date, then there would not be any second exam happening, right?
Mm-hmm. Okay, understood. Thank you.
Should we print all the materials or can just check them on tablets? Okay, so uh, Zong, in previous years, when there was a physical exam, we allowed 2 A4 sheets paper, right? And students could write any formulas there and anything there. But I mean, in our whole course, there's not that much formulas anyway. So that's why in this format we are saying it's like an open book format. So you can use and lecture notes on your tablet. It's not a problem. And you could use the material. I don't know. You can also open it on your browser, because that would also be possible. So when you attempt the TUM quiz, I think on Moodle you are not blocked from using any other application on your uh, device. Okay, so don't worry about that. Is it possible to change your answers once we find we made a mistake? Yes, I think I believe I have answered that. Li Xian Zhang, did you got your answer for to this question, please say yes in the message so that I understand that everybody is. So thank you, Nishan. Okay, so yeah, that's answered. Must each question be submitted individually? No. Like I told, you could always go back and forth. You could have all the fun there, but the main point is that at the end of the day, when you have submitted it, then it's submitted. Okay, then there's no going back or second attempt. Jim Sao, it is possible to share an old exam from the former years. It's not possible. We do not do that here. Okay. Usually, yes. How do you plan to do model tests with broken Moodle website? Ah, yes, that is actually a very, very crucial point, and this is what we are working on. But in the department, we have discussed and that this is very, very from the data protection and data confidentiality point of view. Model test is the best option, and also is the easiest to grade and mark. And because we in from the TUM guideline, we have to keep the record of all the papers for some number of years, and with Moodle we have that already incorporated. So it's, I mean, although Moodle is broken, but still it has many advantages. So I mean, we will try to make sure that there is no bug in the test, right? And that's why we will do the mock exam, with some funny questions. But anyhow, anything can happen because at the end of the day, we try our best to do. But this is a very, very tricky situation, and nobody knows exactly uh, what's the best part or what is the best answer. Okay, maybe set up an emergency hotline that we can call. Yeah, Julius, that's really interesting. I think I will note that down. I will note this down. No, that's an excellent suggestion. I mean, we were also discussing that, but I never thought of this, that it could happen because of the Moodle. So one possible answer could be, or one possible choice could be that what we do is that we, for example, have Zoom session available to the students, and students can unmute themselves and ask a question there if they are experiencing some question, some problem, right? So that could be arranged in some sense, but then there's still uh, some technicalities which need to be figured out. I will discuss that with the professor. So anyhow, I hope everything goes smooth. So are there any more questions? No. Okay, so now let's just, how much time we have? How many lectures relevant to the exam are left as of today? When will we get a new assignment? Oh, Mortis, today is your lucky day. Moritz, I wished you had wished for something else. So today you will get an assignment. Congrats. Damn. Okay. So today you will get a new assignment. I mean, bye. Don't say bye. So I mean, it was already planned. Don't worry. So I will share you the assignment number 3. It is the third assignment, and before going into that, there's another. No. Everybody gets an assignment. Okay, I will now show you something like the exam percentage distribution. Okay, today I am in a very revealing mood. I'm revealing all the secrets, and then we will see the exam structure, not the exam itself, the structure. Okay. Okay. So, oh, you're seeing everything. So this is pretty much the plan. Tutorial 14, 6 is today. Then we have tutorial 7, something like that, right? And then we have tutorial on 8, tutorial number 9. And then probably tutorial number 10 on February 11 will not be happening. But I will discuss that also in the, announce it also in the Moodle. So this is a plan. Okay. So now let's see what you have asked for the assignment number 3. So it was already in the plan, just to clarify or just that you don't kill more Moritz. But before going that, I want to show you something else. Yes, this thing, assignment grading exam percentage. So this is the grading scale of the exam, of the assignments. So you have 23 to 25 numbers, then you get a 1. If you have 21 to 22, then you get a 1.3. And then if you have 19 to 20, then you get a 1.7. And if you have blah, 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 if you have 5 to 6, then you get a 4. Okay. So it is quite lenient, in my opinion, quite lenient. So you would have to be really, really bad if you go below 2.0. So it means that you did not understood something correctly in the lecture. But still, it could happen to somebody. Uh, but normal students do get in this range for the assignments at least. Okay. So does everybody see the exam percentage thingy? Or my favorite MCQ? Oh, where is it? Oh, we lost it. Okay. Oh, where is the chat? Yes, here's the chat. This chat is really tricky. Patrick, when do we get the feedback for assignments? Very interesting question, Patrick. I left that question behind on purpose because I don't have the relevant memes for that ready. So probably in the next tutorial, I would have the memes and then I would also share the feedback because yeah, they're really important. Memes are really important for the assignment feedback because I saw a lot of things which only occur in memes happening in the assignments. Okay, but you would get it soon enough. I would say for the assignment 1, maybe definitely before the next tutorial, definitely. Also probably for the assignment 2, it would be on the Moodle. Don't worry. I mean, the good news is like it's already, like I told you, the range is this 1 to 2. This is for the most of the students. It is this. Okay. Uh, okay. I will just in case note this down this question so that I don't forget. Okay. Great. So now coming to the weightages. I think we already announced in the lecture. This would be the weightage. So assignment 33.33% and written exam which would be approximately 90 minutes 66.67%. Okay. And what would be under the hood calculation for the grade, right? I'm going to show you that. So it would be something like this: 40 multiplied by exam grade plus 6 multiplied by first assignment plus 7 multiplied by second and plus 7 multiplied by assignment number 3. So this is how this assignment number 1 is uh, multiplied with 6. So it's not that much of a difference, believe me. But still, this would be the actual formula which is happening under the hood. And I think you guys should know it. And I would try to also post it on Moodle. Why not? Everybody can see it. Okay. And then we divide this thing and then we take the floor of this whole thing and then we divide it by 10. Okay. So this floor is the mathematical floor. Okay. I hope you guys know it. So are there any questions to this formula? It's pretty straightforward. Patrick, please say yes or no in the chat. Great, thank you. So yeah, you're welcome. So today was a fun day, right? We did not discuss too much things in detail. Okay, before going to the assignment number 3, so announcement. I think I should show you the exam structure. Okay, I will not show you the exam, but this is one possible exam which is there, and the exam, final exam would follow the similar structure. So I hope you guys all can see my screen. Please say yes. This is really important, and you don't see any what is called any any actual question. This is also important. So we have different sections in the exam. So they will not probably they will not be named. We would try to keep the name of like this, but even if they are not named, you should know that this would be the overall structure, right? So we have tried to give importance to each section. Like somebody asked that which elements, which lectures are relevant to the exam, right? So Moritz, you got your wish. You got your second wish today. So feed-forward neural networks, we would have 4 questions, and then we have kernel method, 4 questions, and then we have logistic regression, 4 questions, and PCA and SVMs. So right now, I think we have covered everything, and now only SVMs remain. Okay, so these are the 4 questions which remain. Yeah, so that's pretty much it. So we would basically do. There would be an image, and then you have an option to select option A, B, C for the options of the from the image. You know, so it would be really simple format of for the exam. Okay, I'm just and there would be also some general questions. General questions mean things which you should generally know if you have taken an information retrieval course, and if you don't know them, then probably we did a very bad job. Okay, so they would be quite easy in my opinion. Okay, so let's just say that what is this general statement? So this general statement is just for like a general setting. So this is from for the feed forward neural networks. Okay, so it would formally define the problem for which we are expecting you guys to answer the MCQs. Okay, so and this is a very general statement, and this is just so that you guys are familiar with the notation, and that would be consistent in the exam. So for example, I'm just showing you the actual statement for from the paper uh, for the feed forward neural network. So it would be something like this: that let x of p, let x belongs to rp be the input variable, y be the output variable, blah blah blah. Consider the problem of training and feed forward neural networks f that predicts y given a realization of x. In the following, we assume that the neural network f remains repeated multiplication with the weight matrix wl and element wise activation function. So this would be like this is formally defining the problem, and then we measure the loss function by blah blah blah. Okay, and optimized by a variation of gradient descent back propagation. So this would be like a statement so that you understand the whole context of the next MCQs. Okay, and then if you don't understand the notation, then you can go back and see what was the general statement, what is x and what is y, because in some cases one can easily forget what is x and y. You know what is w, what is sigma. So you can go back and see what is the notation. So that would be included in the exam. And hopefully it should not be that much problem for you guys. Uh, so yeah, that's pretty much the structure of the exam. Are there any questions to the structure of the exam itself? In the chat, please. I cannot. I mean, I'm trying to get this telepathy power, but I really cannot get it. It's quite hard. Guys, so if there are no questions, then I then I close this subject of the exam structure. You will probably not get a second chance. What if we don't understand a question? Can we ask somehow? Again, Patrick, with good questions. Yeah, so that's why we are thinking of this Zoom channel, you know, and then in Zoom you can have breakout rooms, and then if somebody has a question, then we can create a breakout room for him, or he can just ask it, unmute himself, and we would be there, and he could ask this question, and we could try to answer it. So we will figure out the modalities of that. But I mean, in the years we have conducted this exam for like past 10 years, Martin has conducted this exam, and I think things are pretty straightforward. They are well defined. So probably there's no ambiguity left. You would not need it, but still we will have some back channel for that. Okay, so that's why we are including this, these general statements, so that everybody uh, understands the context and the notation. There's no confusion. That's why we clearly and very precisely define um, the notation. As you can see, this is the notation for the principal component analysis, and everything is defined here. Okay, so any other questions? So there is a person I cannot know he's a person or a robot or a bot. 10287. Are you a person? Oh, great. Just kidding. So, what is your name? I don't know how I should address you. So, Mr. 10287, it would be a multiple choice question, right? But you can only choose one single option out of that. So I mean, you have three choices, and only one is correct. Okay. I think I need to show you the sample again. Yeah, like this. You have four choices, right? And only one is correct. If this is not clear enough, then probably let's go to the final exam. I should be very careful. Okay. So it would be something like this. Consider a vector x, 1, 2, 3. Which one of the following does not hold? So there will be three options. You have to select one option. I don't know, what do you call it? Multiple choice or one option choice? Is that clear, Mr. Person? Okay, I like single option. Thanks. Oh, okay, great. Can we check the general statements? One, Aramilo. What do you mean check? I mean, check for check for what? Please explain this question. One, please explain. You want one? One. You can unmute yourself. That would be great.
Yes, well, I was wondering, maybe just to really quick, just for understanding the notation, as you already, as we already checked for the fieldwork neural networks and principal component analysis.
Yeah. So
Maybe
yeah. This general statement would be available in the exam. Okay, and we will not upload it today, or I mean, it is just that you understand the setting of the exam. Okay, so the notation is probably more or less the same as the lecture notes, but sometimes the professor uses a different notation in the lectures. Sometimes, for example, he calls something G, whether it is called K in the in the exam, in
Yes.
the lecture notes. So so people might get confused. So that's why we will define the notation in the exam. So yeah, I mean we cannot share it beforehand. I mean I just showed you so that you understand that there should not be any notational confusion, and the notation in the exam is supersedes every other notation.
Okay.
Yeah. So it's just for
Okay.
like for the purpose of clarity, right?
Mhm. Okay.
So
Yeah.
I mean I just showed you today because you guys should keep this in mind that that problem will be very very well defined. So there should not be a question on the notation or confusion on the notation. Okay.
Okay.
So, yeah. Okay. I think that was transparent enough and everybody understood it. And now we have very limited time left. I think 10 minutes. So maybe let's take a 5 minutes break. Oh no, or maybe we'll leave 5 minutes early. Okay, so let's go to the assignment number three, man. Where's assignment three? Okay. I mean, today we had this lab six, but let's do it some other day. So this is assignment number three, uh, and I will upload definitely it on the Moodle with all the instructions and stuff like that. And yeah, so today you are given this assignment 14th of January, and the due date is 3rd of February 2021, 10 p.m. Germany time. If the time is not mentioned, then Germany time is the reference. And all the instructions are the same. Solutions must be handled in groups, blah, blah, blah. So they are probably, I mean, they are mainly related to this color trick thing. Okay. And for example, on Moodle, you find already some Jupyter notebook with this. And then you have little PCA, blah, blah, blah. And you have to then do all these tasks, which are straightforward enough, in my opinion. And you have to make a gram PCA function, and then you have to show that the gram PCA yields uh, uh, results which are equal to linear PCA. I mean, when you have X transpose X, I mean the linear kernel, then your gram PCA and linear PCA should yield the same results. That's pretty straightforward. And then we use this Gaussian kernel, right? And we use that and show that the Gaussian kernel can solve some problems very beautifully as compared to the linear kernel PCA, right? And then we test this with some MNest images. Okay, and we also define sigma is equal to 10,000, sorry, 1,000. So that's pretty much it. Are there any questions to this assignment? If there are any questions, please ask in the chat. So I take it there are no questions regarding the assignment. It will be uploaded today, and you can submit it till 3rd of February. Yeah, that's pretty much it for today. There's not enough time left for us to start this lab 6. So we will start it probably in the next time. Okay. So let's just move this lab 6 to the tutorial. So on 21 January we will do this kernel PCA tutorial and this Lab 6 kernel PCA theory tutorial and convex optimization exercise, little bit small exercise. Okay, back to my favorite screen. So guys, we have only 5 minutes left, and if you have any question, then please ask. Otherwise, I will just close this session regarding the exam and everything, because I do not want that people keep asking in emails a lot of questions regarding exam. Since this will also be uploaded on the YouTube channel, so you guys can easily go through it if you missed anything, and also we will try to announce things on the Moodle. But if you still have some questions, then please ask. So no questions. So then I wish you good luck with assignment number 3, and you will get the grades for assignment number 1 and 2 hopefully very soon before the next tutorial. I will try. And yes, because the one essential ingredient, which is memes, is not ready yet. So yeah, that was a problem. So, but I will share the results with you. Okay. So take care then. Bye bye. Thanks everyone.